In this video, we will understand the binary search algorithm. First of all, we will try to understand the procedure with the help of a numerical example that how the binary search algorithm works. Then we will write the algorithm and will find the complexity of the algorithm. In this video, we will understand the binary search algorithm. First of all, we will try to understand the procedure with the help of a numerical example that how the binary search algorithm works. Then we will write the algorithm and will find the complexity of the algorithm. After that, based on the algorithm, we will write the program. So, binary search is also called half interval search. There are some other names, half interval search, or it is also called logarithmic search because the complexity or the search time is logarithmic, that is log n base 2. And binary chop because it divides the whole list into two parts. So these are some other names of the binary search. And let us understand the analogy of binary search, that how the algorithm works. Suppose you want to search a word in a dictionary. So what you do, uh, we actually do the estimation that where the word can be found in the dictionary. Accordingly, we open the pages of the dictionary rather than opening the pages sequentially. So thus we search, and if we found that the word is smaller than uh, the opened page, then in that case either we ignore actually right hand side pages and we try to search on the left hand side remaining pages. So based on this analogy, the algorithm logic also works. The Here you can see we basically ignore half of the element just after one comparison, and we compare. Here the difference is that we compare always with the middle element, while in dictionary we do the estimation and that where the word can be found, and accordingly we compare the word. If the number that we want to find x matches with middle element, then we return the location of the middle element. Otherwise, if it is larger than middle element, then uh, we are confirmed that the element is on the right hand side of the sub array. Why this is so? Because the requirement of binary search algorithm is that the elements must be in sorted order. This is the first requirement that we will see later on. Otherwise, if it is smaller, then we uh, do the searching on the left hand side of the remaining array. Now let us understand this procedure with the help of a numerical example. So suppose we are having a list of elements 2, 5, 7, 8, 10, 11, 15, 16. Suppose this is the number of values list where we have to find a some number. So this is the array A, we can assume, and these are the indexes 0, 1, 2, 3, 4, 5, 6, 7. So number of elements here are 8. And we are considering the index starting position 0. We can consider 1, 2, 3, anyone approach we can follow. So this is the procedure. We are taking 0 because we want to make it closer to the programming language. So these are the indices. So now suppose the number that we want to find is, say for example 7. We want to find number 7. Okay, so what we will do, first of all we will calculate the index of mid element. So index of mid element will be beginning this starting index we are considering as beginning and last index we are considering as end. So we will find the mid by taking average beginning plus end divided by 2. So this will be 0 plus 7 by 2 is equal to 4. So this is fourth element. So what we will do, we will compare the number with A of mid element. So A of mid is what? A of 4. A of mid means A of 4 because mid is 4. So we will compare 7 equal to 4. Number is 7. 7 is equal to 4. No. Number is not found. So what we will do? We will check whether number is smaller or larger than this element 10. So if number is less than A of mid, then what we have to do? We are confirmed that the number will lie on the left hand side subarray because it is smaller and array is in sorted order. Otherwise, if number is larger, then it will lie on the right hand side subarray. So here what we have to do, after first comparison we have to shift the end index to 1 before the mid element, that is here. So what we have to do, end is equal to mid minus 1. Otherwise, because here we have compared with equality, here we have checked for number whether it is less or not. If this case also becomes false, then what will happen? Number will definitely will be larger than the A of mid. In that case, if number is larger than A of mid, so we have to shift beginning to one position ahead of mid. That is mid beginning will become mid plus 1, right? So like this algorithm will work. So for now, C number is not equal to, so here we will check number is less than A mid. So what will happen? Beginning will remain at 0 and will become to what? Mid is 4. So mid minus 1, that is 4 minus 1 is equal to 3. Now again we will find the new mid. So mid is equal to beginning plus end divided by 2. Here we have to do the integer division. So it will not come to 1.5, rather it will come to 1. Integer part we have to consider. Now check whether number is equal to A of mid, A of 5. No, number is not. So we will check whether number is less than. No, because number is 7. So this condition also becomes false. So this will run. Number is larger. So what we have to do? We have to move beginning to mid plus 1. So mid is this. Now beginning will, this is the first case, this is the second case, and this is the third phase. So here beginning will become mid plus 1, that is 1 plus 1, that is 2. And where is the end? End is at 3. So again we will calculate mid. So mid is equal to 2 plus 3 by 2. This will become 5 by 2 is equal to 2. Now this time we will compare again. That is from here we have to repeat the procedure. Okay. So number is equal to A of mid. Yes, A of 2, because this time mid barabar 2. Mid is equal to 2. So number this time found. So if number is found, so what we have to do? We have to return the location. So location will be, we can say that mid plus 1. Why so? Because index is starting from 0. But in real life, we do the counting from 1, 2, 3, 4. So if we have to tell the location, so we will count it from 1 plus 2, 1, 2, 3. So location will be 1 more than the index. So mid plus 1. and after that if number is found, then we can exit the procedure. So here we can write exit statement, or we can write go to, and we can give line number after here, and we can go to jump to any end line. So like this procedure will work. So see here we have to repeat this procedure. So question is that how many times we have to repeat the procedure? What will be the condition in the loop? So now check, see, we are doing the comparison when we are seeing that beginning is less than end. You observe the procedure and we have seen that beginning is always less than end. So we can do one thing here. Okay, we can include some loop here like this. While beginning is less than end. But see, whether we have to do something more or this is enough. So this, so take another example. Suppose we are having 2, 5, 7. Now we have to compare the number. This is the list, new array, 0, 1, 2. Now we want to find 5. Suppose number is 5. Check. First we will calculate mid. So mid is equal to 0 plus 2 by 2 is equal to 1. So mid is 1. Now see, we have calculated the mid and beginning is 0. End is 2. So see here, after this loop we are calculating the mid. Then we are comparing the number is equal to a of mid. Number is equal to a of mid. So a of mid is what? A of 1. Number is equal to 5. If number is equal to 5, then we will return. Okay. And now suppose in this list we want to find 2. So what will happen? Instead of finding number 5, this time we want to find number 2. So repeat this procedure. First we are calculating what? We are calculating mid. So mid will come 1 as 1. Now we will compare whether number is less than a of number is equal to a of mid. No, number is not equal to a of mid. So we will check whether number is less than a of mid. Yes. So what we will do, we have to shift end towards to one position before the mid. This is mid. So here beginning will remain at 0 and end will be what? Mid minus 1, and mid is 1, so end will be 1 minus 1 and 0. See, here beginning and end are at same position. In this array 2, 5, 7, beginning was here, end was here, but after first comparison we have moved end to one position before he mid. So here you can see beginning and end both are at same position. Now this is in second comparison. Now see, till now we have not compared the number with this element a of mid, but we have to compare it. So this means we have to run the loop for this case also. So here equal to condition is must. So if beginning equal to end, that is beginning and end both are at 0, 0 is equal to 0. So we will go here. So we will calculate 0 plus 0 by 2. This will come 0. Number is equal to a of mid. Then it will print number's location and will come out. After this loop is running from here, and the statement inside the loop are these statements. Okay. After this, what we will do? We have to check whether number is found or not found. So here the condition is that if number not equal to a of mid, Then here we can initialize location is equal to something like -1, because location cannot be a negative value. So here for the algorithmic purpose we don't want to include print statement. So we are initializing location variable as -1. So like this algorithm will work. Now what we will do next, we will write this algorithm in the fair way, and we will try to find out the complexity of this algorithm. So we will write the algorithm properly. Now see here, while beginning is less than equal to end, then here we are using begin statement because we want to write algorithm according to design and analysis of algorithm DA. So we are not using braces because braces is a programming construct, and we don't want to include any programming construct in writing while writing the algorithm. Instead of writing this less than equal to, we may also write less than equal to like this. Okay. So here what we have to do, first we have to calculate mid. Mid is equal to beginning plus end divided by 2. Here it is integer division. Integer division. Okay. Then we have to compare the number num is equal to a of mid. If number is found, then here we have to write the location is equal to mid plus 1, or you may also write location is equal to mid, no issue in that. And we have to come out of this algorithm. For that we can write exit or return like statement, or go to, return or go. Go to will come to the last. Return we will write if we are making this as a procedure. Otherwise we can write exit. So here we can use end if statement. Okay. Now we have to check if number is less than a of mid, then number is lesser, so n will come to mid minus 1. Else or otherwise beginning will move after mid, that is mid plus 1. So this is the algorithm, this is begin, and here we can write end while. And after that one more statement we may write, that is if number not found. If number not equal to a of mid, in that case we can initialize location is equal to -1. So this is the algorithm. Some things, some variables here we can initialize, like beginning is equal to 0, end is equal to n minus 1. Okay. Otherwise you can write 0, 1 or n. Okay. So these are the steps. We will give some sequence number 1, 2, 3, 4, 5, 6, 7. This is 7th line. 8th, 9th, 10, 11, 12 is else, 13 is this, 14, 15 and 16. These are the steps. Now we have to calculate the complexity. So here we have to write Two columns we have to make. Number of times, this is, here we can write cost of execution of these statement, and then we have to write number of times statement will run during the whole execution of the program. So let us assume the cost of execution of this is C1, C2, C3, begin is C4. So cost of execution of this braces we can write 0. Unnecessary increasing the variable is not needed. So this C4, C5, C6, exit C7 and 0, C8, C9, this is 0, C10, then 0 and C11 and C12, like this. So this is cost. That is, there some operation beginning is equal to 0. In this statement, some operation is involved, and suppose it is taking C1 time, constant time. Okay, so this is the cost. So here we have to check how we have to write how many times this statement will run. So begin will run one time, this will run one time. Now see how many times this we have to check. Begin is less than this loop, how many times will run. So this is the main thing that we have to decide. So we can write it here. See, suppose we are having 1, 2, 3 up to 1000 elements, say for example. Okay, now see, this is beginning and this is end. Now see, because we have seen that in the procedure that after each comparison the list is being divided into half, and at the same time half of the elements are discarded. That is, our problem size is reducing to half. Suppose we are having n elements in the beginning, so next time we will be having n by 2 elements. After that we will be having n by 4 elements. So suppose we have to compare, we have to search our number, desired number in the list of 1 to 1000. So after first comparison we will have only 1 to 500 values. Suppose number is smaller. After this we will have 250 values, like this. So see, the you can check that how many times this statement will run. So take one more example. Suppose we are having 16 values. So after first comparison we will have almost 8 values because it will be divided into almost half. So after that 4, then 2, then after this 1. So here if one element is there, then no need, okay, so of division. So we are taking how many divisions? We are taking only 4 divisions. If 16 elements are there, then we are taking 4 divisions. That is, how many times this will run? Log of base 16, log of 16 base 2. So if we are having n elements, so how many times this statement will run? This will run log n times. This statement will run log n base 2 times. And we know that the statement inside the loop always run one less than the number of times loop is running. So it will run log n base 2 and minus 1. This statement will also run same number of times, because all these statements are inside loop. So this will run. Similarly, last statement will run one time. Okay. So what we have to do now, we have to write the complexity expression for this. So complexity expression, we have to do this multiplication. That is, here we are writing in brief, and later on we will do the calculation. So complexity expression Tn, where n is the input size or problem size, this will be C1 into 1 time it is running, then C2 into 1 plus C3 into log of n base 2 plus, here you can see C4, C5, C6, C7 all are multiplied to this. So C4 into, because space is not there, so just understand it verbally. C4 into log n base 2 minus 1. So this will come to C4 into log n base 2 minus C4. Similarly, C5 into log n base 2 minus C5. So here we can see that the maximum degree polynomial, that is of n, is what? Log n. Okay, because see here C5 into log n, C6 into log n minus C5 minus this type of expression will be there. So we are finding that we will get an expression like this: time taken to solve, time taken to search n element, Tn is equal to what? Some constant. Okay, like it was C3, C3 into log n. So this will be C3 into log n plus something like C5 plus something, means some constants will be there, into log n base 2, here plus and minus. Some statements may be like minus, like C1, C2, C1 and C2 will be in plus constant, and here you can see some, here we got C4 in the minus, C1, C2 minus C4. So it will be C1 plus C2 minus C4 up to some constants here. So see, here we are getting some constant, sum of constant will always be constant, constant into log n base 2 plus some constant b, where a and b are constant. So while writing in asymptotic form, we ignore the constants, okay, and we just write the term which include the input variable n. So Tn can be written as order of log n base 2. So big O notation gives the maximum time. Similarly, we can find out the minimum and maximum time, and we can represent in the form of theta notation. But our aim right now was to understand the complexity, uh, not the asymptotic notations. Now this is the first method to calculate the complexity. Now we can have another method, that is recursive method, to find complexity. Okay, here we will also discuss this method. Okay, so see, here we are having, we will make 3 columns here. level, here problem size. So level 0, problem size is n, and time taken. Yeah, time. So we know that we suppose there are n values, n input size, and problem may be anything like searching, sorting, sum of numbers, any problem. But that involves n as an input size. So to solve that problem, how much time it will take, we can write in terms of variable Tn. This is a function actually, and sometimes it is a polynomial. Okay, so this function is a polynomial. So if there are n values, then to solve this problem, time taken is Tn. If we are having x input size, problem size is x, then time taken to solve that problem is x. If there are 5 numbers, we want to sort these numbers, so how much time it will take? T5. If there are 5 numbers, we want to search a number, then with any algorithm, so time will be T5. This is the representation. Why I am writing this? Because if problem size is n, then time taken will be n. Now in case of binary search, see, now in case of binary search, after first comparison, the problem size is divided into half. Initially we were having n elements to search. Now after first comparison, we are having n by 2 element to search. So our problem size in the next level 1 is becoming n by 2. So time taken, that is time taken to solve this problem or time taken to search an element, will be Tn by 2. Now see, after next level, after this level, the elements will reduce to half, so problem size is n by 4, so time taken will be Tn by 4. Similarly, we know that after kth level, which is the last level, problem size will definitely reduce to 1. We will keep on dividing. At the end, we will have only one element in the list to search. So problem size is T1. Now time taken to solve a problem with input size 1 is T1. Okay. Now see, the task involved in each level is what? To compare the number with mid element. So if we are having one element at the end, so time to compare the one element will be constant order of 1, or we can assume it as 1. Similarly, in each level we are doing the comparisons. One comparison. So you can see the total time to solve the problem of size Tn will be what? 1 plus 1 plus 1 plus how many times? This is k time. 1 plus 1 plus this, how many times? K times. Okay. Now see what is k? K is nothing but log n. That is number of levels where it will be divided into sub problem of size 1. So k is nothing but log n base 2. Okay, so we can say at 1 plus 1 plus how many times? Log n times base 2. Suppose we want to add 1 plus 1 2 times, so answer will be 2. We want to add 1 plus 1 100 times, so answer will be 100. Similarly, here also if we want to add 1, how many times? Log n times, so sum will be log n base 2. So Tn is what? Log n base 2. So this we can represent in the terms of big O notation, log n base 2. So like this we can find out the complexity with the help of recursive method. Now this algorithm we have already discussed. Okay. Now see what are the requirement of binary search, that when you can apply the binary search. So first thing is that elements in the list must be in sorted order. First and foremost thing is that sorted order list we should have. And one more thing is that because we are calculating the mid index, so there should be direct access to mid element. So this is possible in case of only arrays. So we can use binary search with arrays because we can directly access any element in the array with the help of index. So this is not possible to apply binary search if we are maintaining the list of values in the form of linked list, because there we cannot find the mid element directly. So these are the two requirements that we must understand before applying the binary search. Okay. So these are the requirement. At the same time we are having some disadvantages, like if we are using array and we are not having the complete list in advance or a prior, in between elements are being added or deleted, then what is the problem? That we have to shift the each element downwards, or if we are deleting then we have to shift the following elements upwards, which takes time. So this is one problem. Another problem is that if we are having non-sorted input, so we have to do the sorting first, then we can apply the binary search. So these are the requirements. Okay. Now understand how to write the program for this. Here we have written the program in C language. So header files we have to include. This we have taken initially 10 size dimension array. We can rather make it a constant with the help of max, and we can here define as 1000. Okay. So maximum size here we have declared as 1000. So instead of writing 10, we can here write as max. Okay. These are the some variables declared here, and here we have option that not necessary to input all the 1000 element every time, but maximum we can have 1000 elements. And here we can take input. Suppose we are having list of 5 elements, so we can give input 5. If we are having 10, then we can give input 10. Then after that we have to enter n numbers. Suppose 5, so we have to input 5 numbers. So here we have not used braces here because for loop is having only one statement, so these braces are optional. So it will input 5 element to a array a0, a1, a2, a n minus 1. After that we need to input a number that we want to search in the variable num. Then we have initialized beginning end like in the algorithm. This is the same loop condition that we have written in the algorithm. Then we have calculated the mid. Then we have compared double equal to, because programming is there C language, so it need double equal to. While writing the algorithm we have used single equal to. Okay, so here in programming we can print it the location mid plus 1, and after that we can use break statement, because if number is found then we can come out of loop. This while loop is ending here. Otherwise if number is not found, then we can check it for whether it is greater than or lesser. So if it is greater, then we have moved beginning, afterward the mid, and otherwise end. If number not equal to a of mid, then we have printed not out, not found. This is another version where we want to search string or name in the given list of names. So this header file for string manipulation, and this is character array we have to declare in C. Instead of writing 10, suppose we can write give higher dimension here, 1000, maximum 1000 names we can. This is double dimensional array. So C 1000 is the row, so 0, 1 to 999, and 30 is the column, so 0, 1 to 29. So here in each row we can store one name maximum whose length can be 30. So like this we can store maximum 1000 elements strings in the array. And here we have taken n is equal to 5 strings. Suppose we are having, we can take input for n here also. Then to get a string we have used gets function. Okay, we can also write scanf, but it takes single word. It will not accept Amit Kumar where string is having space. So if we are using percentage s and a of I, then it will scan or accept only Amit, not Amit space Kumar. We can do some manipulation here in the control string to accept the string with spaces, not slash new line like this. Okay, so that is not needed now. So you can directly use gets to get a string. Then we have to input the number, oh sorry, name that we want to search. Then rest of the procedure is similar. Beginning, here you have used what? strcmp function. strcmp function here we have used to compare name and a of mid, because double dimensional array, a0 will have first name, a1 will have second name, a2 like this. So this will compare, and if names are equal then it will return 0. There is one more function strcmpi if you want to ignore the case sensitivity of string. So ignore I for ignoring case. Then we have printed the location, otherwise we have updated the index position of beginning and end element. So this is the program to search a name in the given list of names. Okay. This is the recurrence relation method to search a binary search. You can see it here. At each step, binary search perform one comparison. It checks whether key is equal to middle element or not. Key means number. Then recursively searches in one half of the array, either left side or right side. Hence the recurrence relation will become, if we are having n elements, so we are having one comparison with the mid element, and next we have to do the searching in n by 2 elements. So we have written t n by 2 plus 1. So this is the recurrence relation, and we can solve it using substitution method, or we can solve it using master theorem, and we can find out the complexity in this way. Best case complexity will be 1, because in the first comparison if element is found, so that is the best case. So this is the recursion tree that we have understood. Okay, we have understood. So that's all for this video. Thank you.